Okay, we have a problem here. It states a car starts moving from rest accelerates uniformly at 2.5 meters per second squared for 20 seconds. It further accelerates at 2.0 meters per second squared for 10 seconds to reach a constant velocity. The car then maintains the velocity for 30 seconds, after which it uniformly retards to rest. If the whole journey takes 100 seconds, A. Draw a velocity time graph to illustrate the motion. B. Calculate the total distance traveled. C. Calculate the retardation that brought the car to rest. And D. Calculate the average speed traveled by the car. So we have a velocity time graph problem here. What we can first try to do is let's try to sketch the graph. So we will have velocity in meters per second on the y-axis, and we're going to have time in seconds on the x-axis, and we indicate the origin 0. So if we should go on to sketch the graph, what it states is that the car starts from rest. So it starts from rest and then accelerates uniformly. This is how you illustrate it. And what was the duration of the acceleration? The duration of the acceleration was 20 seconds. So after accelerating at 2.5 meters per second squared for 20 seconds, it further accelerates at 2.0 meters per second. This is how we're going to illustrate it. Further accelerates at 2.0 meters per second squared for how many seconds? For 10 seconds. So if we add it to the 20 seconds that has already been previously traveled, the total will be 30 seconds. Okay, then what happens after the acceleration? The car reaches what? It reaches a constant velocity. So, and then maintains that constant velocity for what? For 30 seconds. So if we should add it to the previous, we're going to have a total of 60 seconds. All right. Then later on, what happens to the car? It uniformly retards to rest. Okay, the car uniformly retards to rest in a total of from the question, it says the total distance travel, it takes 100 seconds, so which means we're going to have 100 seconds here. All right, so going quickly over it, we're going to have it accelerates uniformly at rest for 20 seconds, then accelerates at 2.0 for 10 seconds to reach a constant velocity. It then maintains that constant velocity for 30 seconds, after which it decelerates to rest. So it means the time for deceleration would be 40 seconds. If you look at it from 60 to 100, it means the deceleration or that brought the car to rest will be 40 seconds. Okay, so if we look at it, we need to find the velocities. Okay, for the first acceleration, we need to know the velocity that has been reached. Let's call that v1. And then the second velocity, let's call it v2 at the end of the second acceleration, v2. Okay, all right, so using v is equals to u plus at, so we can say v1 is equals to u1 plus a1 t1. That is the first event. Okay, so what will be v1 is equals to u1, the car starts from rest, so obviously the initial velocity will be 0 plus what was the first acceleration is 2.5, and in how many seconds was that covered? 20 seconds. So what are we going to have as v1? V1 will be, if you should calculate that, will be 50 meters per second. Okay, so I can just continue, and instead of writing V1, I can just go directly and indicate 50 meters per second there. Okay, so let's continue and find V2. Okay, V2 is equals to U plus AT. Okay, or let's just say first V equals to U plus AT. So if I'm going to find the final velocity for the second event, it will be V2 is equals to U2 plus A2 T2. So V2 is equals to, what will be the U2? U2 will be, that is the initial velocity for the second event, would be equal to the final velocity of the first event. What was the first final velocity for the first event? 50 meters per second. So that will be 50 plus what was the acceleration in the second event is 2 meters per second squared times what was the time for the second acceleration. It was 10 seconds. Okay, so what are we going to have for that? That will be 70 meters per second. So we can go and substitute V2 as 70 meters per second on our velocity time graph. Okay, so instead of having that, I will write 70 meters per second. Okay, so we move on. The first question says we draw a velocity time graph. That is A. We have done that. So the second question is asking us to calculate the total distance traveled. To know the total distance traveled, we need to calculate the sum of the areas that we have for the entire journey. So we can say this is S1, it looks like a triangle. This is S2, looks like a trapezium. This area is S3, it looks like a rectangle sort of, and S4 looks like a triangle. So if we should just trace the shape out, this is how S1 looks like. So we're going to have 20 and we have 50. So that's S1. Okay, so what is the sum of area of a triangle? The formula for the area of a triangle is half base height. So what is the base? The base is 20, and what is the height? The height is 50. So that gives us what? That gives us 500 meters. So that is S1. So we can move on to find S2. So how is the shape of S2? S2, this is sort of the shape. It looks like a trapezium. We have 50 here, we have 70 here, and 10 seconds there. That's the time. So if we should find the area of S2, is S2 is equals to half A plus BH. That's the area of a trapezium, where this side will be A, this will be B, and this will be H. So S2 will be half. What is A is 50, what is B is 70, and what is the height is 10. So what do we get as a total? We're going to have 600 meters. Okay, then we move on. We can look at the shape of S3. We say it looks like a rectangle. Okay, and S3, this is the shape of S3. Should we move on? So that is, the base is 30 and the height is 70. Okay, we have 30, and the height is 70. So S3, the formula will be base times the height. That's the area of a rectangle. So what is the base? Is 30 times 70. What do we have? So 30 multiplied by 70, we have 2,100 meters. So we move on to find the area of S4. S4 looks like a triangle, and this is how S4 looks like. Okay, so what will be the base? It is 40 seconds, right? Okay, 40, and what is the height? Is 70. So area 4 is equals to half base height, that is the area of a triangle. So this should be half. What is the base? Is 40. What is the height? Is 70. What do we get? We have 1,400 meters. Okay, so that is it. So the question asks us B to find the total distance. Okay, so we're going to move on calculating the total distance. B, the total distance S total is equals to S1 plus S2 plus S3 plus S4. And what is that? S1 is 500, S2 is 600, S3 is 2,100, S4 is 1,400. So what will be the total for that? That will be 4,600 meters. Okay, so we move on to answer question C. Question C says calculate the retardation that brought the car to rest. So the retardation that brought the car to rest is what we're going to find. And how do you calculate that? Okay, using V is equals to U plus AT, we know that acceleration is going to be V minus U all over T. Okay, so because the retardation is in the fourth event, so let's just say A4 is equals to V4 minus U4 divided by T4. So what is V? The final velocity, when a body comes to rest, the final velocity will be 0 minus what is the initial velocity? The initial velocity will be from the point it starts to decelerate, which is 70. Okay, and what was the total time taken during deceleration will be 40 seconds. All right, so what do we get? We're going to have minus 1.75 meters per second squared. So that is the deceleration. Okay, now when we move to answer question 4, the question 4, it says calculate the question 4 asks us to calculate the average speed. So the average speed is equals to total distance divided by the total time. And what was the total distance? 4,600 meters. Total time travel was 100 seconds. So that will give us 46 meters per second, right?